Hello. So thanks a lot for coming to this load testing crash course. Um, so my name is Stéphane Landelle. I created an open source project named Gatling something like 12 years ago now. And for 5 years, I've been co-founding and running a company named Gatling also. So we created a company to back up the open source project. So you can find my handles typically on Twitter and GitHub. And I come from France. So I wanted to give this talk because so I've been in the load testing field for something like a bit more than 10 years, and honestly, for all this time, I've observed the same kind of patterns of mis uh, mis misdefined load testing requirements, and really people don't know how to handle load tests sometimes. Quite often people don't run load tests at all. So I wanted to get an opportunity to fix that and properly teach people how to properly craft load testing. So first, before we dig into the core topic of how to build proper load tests, I wanted first to talk about why you should be running load tests, because quite often people just don't run load tests at all. Even if we say that nowadays we're agile, quite often actually we have some deadlines, and when we need to meet the deadlines, we are looking for things to ditch, and we tend to ditch some tests, and typically load tests are the kind of things that people will decide to ditch. So let's talk about how you should give you some arguments to convince both yourself and your boss that you should allocate some time to build the tests. It's a bit funny because engineers for hundreds of years have been able to build very sturdy things, monuments that would last for centuries. And it's pretty funny how in IT, we really don't work this way. It's really things like, there's a kind of amateur feeling where we just drop applications over the fence in production and just let things crash and just deal with the possible consequences. We're basically crossing fingers that things will go fine once in production. And the core reason for that is that we tend to just trust the functional tests run in Q environments to validate that the application will properly work in production. Remember that the service that you're supposed to provide is not that the application works properly in your environment, that it works properly for your end users in your production environment. And typically in your current environment, the conditions are completely different from what you have in production. You don't have the same kind of traffic, just a few QA persons or a few concurrent end-to-end automated tests. The amount of data that you have in your database is probably very small compared to what you have in your production database. And also there's a good chance that the sizing of your infrastructure in your QA environment is way smaller than what you have in your production system. So basically, if you just trust your functional tests to validate that your application will properly behave once in production, this assumption is just groundless. So, and why should you care? Well, there's lots of events that could cause your application to crash. You're releasing a new version with some major changes, or even sometimes just minor ones, or you thought so. You could have build an application that's supposed to deal with large traffic. You could have seasonal peaks on your application, like you have to deal with Black Friday. And what happens if you crash at Black Friday? That's supposed to represent something like 30% of your annual sales. Also, you could be building a startup. You've built your proof of concept. You've been able to raise money. Okay, so you have this proof of concept of your application. Is this application, this version of your application, will be able to withstand your company's growth? Or is it just a proof of concept that you built, you were able to build fast, but it's not supposed to last? It's not able to withstand more traffic, and you actually need right now to launch a rewrite project of your application so that the new version will be able to withstand the load in 6 months or 1 year from now. But you need to launch this project now because it will take some time to build a new version. And if your users have a poor experience on your application, like slowdowns or possibly crashes, you will suffer from losses. Of course, you will suffer from sales losses. Your potential customers will end up building from your competitors and will end up also getting used to it. And you'll probably damage your brand also. And this is pretty hard because actually it takes a long time to build trust with your users. It just can take one day to destroy this trust, and it's very hard to build it again. And also, if you're just building some intranet application, it means that your end users won't be very productive, as productive as they should in their work with the core application they're supposed to be using. I come from France, and sometimes I experienced people going on strike because their daily work life was just a misery because of the application they were supposed to use. Also, quite often we hear people saying, "Oh, now I've moved to the cloud, so the cloud will take care of the performance issues for me." It's a kind of fallacy, honestly. Even if you have, for example, autoscaling enabled to deal with traffic peaks, in this situation, first the autoscaling won't pick up immediately. And also it will increase your operating costs. You'll be running more instances. Also, another point is that it's more complex to operate a large cluster, a large fleet of instances than just a few ones. Also, if you have a monolith, for example, with a local cache, if you start trying to scale out, you need to change the architecture. And your local cache is becoming a source of bugs, and you need a distributed cache too. So more complexity and possibly more opportunities to crash too. So yes, the cloud can help with lots of things, but it cannot fully make your application fast and resilient for you. So let's see what load testing is actually and how it can help. So first, what load testing is not. Load testing is not about web performance. It won't help you, for example, measure how fast your web browser will draw the rendering of your HTML and JavaScript application. It's a different set of tools for this, tools like PageSpeed. Also, you won't be able really to use headless browsers for running your load test. So it's not a kind of Selenium at scale. The reason for that is that headless browsers use lots of CPU and lots of memory, so it doesn't really scale. If you need to generate thousands of virtual users, you'll need hundreds of virtual machines and hundreds of headless browsers. You can just check how long it takes for your end-to-end test suite to complete in your CI environment. So load testing tools let you actually generate network traffic. They're really focused on what happens on the server side and generate the same kind of traffic that your real users are generating from their web browsers or native mobile apps, for example. And the goal with this is really to simulate realistic traffic compared to what happens in production. So you'll be generating what we call virtual users. So you'll be trying to simulate users having behaviors and completing journeys, typical journeys on your applications. And this way you want to validate your performance requirements. So it means that you have some requirements to define. And so you'll be analyzing the response time, figure out the bottlenecks, fix them. So it's an iterative process. And possibly size your infrastructure or fix bugs in your application. So now the core matter, how to build realistic load tests. So it all usually starts with you want to define some requirements, and quite often when we are in touch with potential customers, we have the business people coming with requirements such as we want the application to be able to withstand 1,000 users for 1 hour, and we need to explain them, I'm sorry, but I don't understand this. It doesn't really mean anything. We need more information than that to properly understand your use case and how you should be crafting designing your tests. So in order to design a proper load test, you need to to determine the characteristics of your application and of your traffic. So first of all, you might be interested in figuring out if your application is stateless or stateful. If your application is stateless, it means that all your requests are idempotent. They don't modify any state on the server side. Typically, don't change any state in the database. In this kind of traffic, typically, the traffic is anonymous. People are not connected. So it means that the traffic can be recorded and can replayed, and possibly replayed in different orders. You don't really care about which virtual user actually executes which request. This is typically the case of a content website. If you just ditch the part where you have a backend for editing the content, then it's just static content directly served from caches. So for this kind of test, it's pretty easy to design a test, actually. You just take a dump of your traffic, like your access logs from Nginx or whatever, and just say to your tool, okay, replay this traffic with this given amount of virtual users, basically. Things start getting more complicated if your application is stateful. So, for example, you're having to deal with an e-commerce suite and an e-commerce website, and of course, virtual users can only flush their cart, purchase, if they have first added some products in the cart. So, in this case, you cannot replay the request in any order, in a random order. You need to figure out the typical user's journey in your application and implement that, implement the different sequence. So, for example, for an e-commerce website, first add products in the cart, and then you can purchase. And so it means that you need to be familiar with the user's journeys on your application. Sometimes you're not. Sometimes you're kind of beginner in this field. You don't have also the proper people in product who are familiar with analytics on the application on the website. So you need to start somewhere. Focus on the landing page, focus on the main core business processes on your application, and then iterate and improve. But really start with something. It's better than just doing nothing. And then if you can get in touch with the business and product people, they might have this kind of analytics and be able to tell you, okay, we have 10% of our users on the website doing this kind of process, and 50% of the users doing this other process. And this way, you'll be able to build a complex traffic mixing different behaviors of different populations of users. So the second point then is to properly configure not only just the code of your application, but also the infrastructure and the network. So quite often, if you talk to developers, really, they will be very focused on what they've developed. And when they consider performance and load testing, they will be just watching their piece of the puzzle, of the jigsaw. But the thing here is that your application is just not just your code and your database. It's also about all the infrastructure and everything that's between the client and your actual code. So there's typically all the network. You can have network issues. You can have problems with your load balancers that are not properly sized or properly configured. So you can also start seeing that when you need to investigate performance issues, the system admins won't have all the answers, and the developers won't have all the answers. So it's probably something that have to do with collaborating with different profiles, different kind of people, and different skill sets. So let's dig into what actually happens between the end user trying to perform a request on your website and your actual code being triggered. So first of all, your users will have to resolve the actual IP addresses of your application, perform DNS resolution. And this means querying different DNS servers until the client is able to figure out the proper IP address. So it means extra latency, and possibly in some architectures, you might have some performance issue with your DNS servers. Maybe sometimes you have your own DNS server, for example, a Route 53 on AWS, because you're, for example, doing DNS round robin between multiple load balancers, for example, when you have to deal with huge load. Then the second step, once you know which IP addresses to connect to, the second step is that you'll need to open a connection to this website. So assuming we're talking about HTTP1 and HTTP2, those protocols are built on top of TCP. HTTP3 and Quick are built on top of UDP, but let's just consider TCP. So it means that also there is, again, some back and forth between your client and your server. And opening those connections consumes resources. It's not just latency, it also consumes some memory and some file descriptors on both the client and the server side. It will use ephemeral ports. And if you need to deal with tons of connections, you might be limited by the number of available local ports for dealing with all those connections. And also, lots of people are not familiar with the fact that when you deal with lots of connections and lots of connections you need to open and close, the local ephemeral ports cannot be recycled instantly. Because TCP has to deal with possibly retransmitted packets. You don't want to reuse the local ports for new connections too fast in a way that you might receive actually retransmitted packets that comes from the previous connection on using these ports. And so end up with a completely broken TCP packets that don't have anything to do with the current request. So dealing with TCP connections consumes lots of resources. And you might run out of these kind of resources and end up with connection timeouts or connection refused. Then probably there's a good chance that you need to upgrade your traffic from clear HTTP to HTTPS, meaning encrypt your connection. And this involves, at the beginning, performing a TLS handshake. So it means, again, some back and forth, two back and forth actually, between the client and the server. First, deciding on the common protocol and surface use, and then performing the encryption keys exchange. And again, this uses some resources. Of course, you'll need some CPU to perform the encryption, but also it uses memory, because every side has to keep in memory its private key and also the public key of the counterpart. So again, you might run out of resources depending on how you deal with connections, and you might have to scale out to allocate more resources. So why is this important? It's because you need to understand what kind of traffic you want to simulate and how many connections and how many connections you want to use, and how many connections you need to open and close per second, because of the recycle ephemeral, because of the recycle of the local ports I mentioned before. So, for example, if you want to simulate public-facing traffic, you want to load test your public-facing endpoints. Your clients will be a huge fleet of, might be a huge fleet of web browsers or native apps. In this case, each of these web browser will open its own connections and get its own TLS keys. So this kind of use case will use lots of resources, both on the client side and on the server side. Okay. On the contrary, if you want to simulate server-to-server traffic, so for example, traffic between two different microservices in your application, or traffic between your public-facing endpoints, like your load balancer, and the actual application being served by your gateway. In this case, there's a very good chance that the client application will be using some kind of connection pooling to save latency and resources. Most load testing tools support both cases. Either have a connection pool per virtual user or have a global connection pool. But you need to pick the proper configuration matching your actual use case. Sometimes we see people reaching out on our forum saying, oh, I have some issues with your tools, like I have some connection refused and connection timeout and TLS inject timeout. How do I fix your tool? What's the tuning to fix this bug? And then they say, okay, never mind. I found out about shared connections and now I'm fine. Those people might actually be designing a completely broken test because they're just making, introducing a global connection pool while in reality, things don't work this way. So, okay, that's great for them. Well, the test runs fine, but the test is completely unrealistic, and their actual users will experience all those connection timeouts and connection refuse and TLS handshake timeout in production. And these are the kind of errors that you cannot see on your server-side monitoring, because the issue is between the client and the server. So you cannot monitor anything that happens before your public endpoint. So the only way to see that is either to run load tests or to have some client-side monitoring from JavaScript to get some this kind of monitoring. You cannot see that from Datadog, for example. So really pick the proper kind of traffic you want to generate. The next point is, so it's about queuing theory, actually. So is your application an open or a closed workload model? And again, you need to pick the proper model, because otherwise you'll be building unrealistic load tests and comparing apples and oranges. So what is an open system model? So it's not something specific to testing, it's something about queuing theory. It can be applied to any kind of system. So an open system model is a system where new jobs arrive independently of job completions. New jobs keep on starting and starting and starting when they're supposed to start. And it doesn't matter if there's already some jobs running. So typically it's a website where people keeps on trying to connect to the website, even if there are lots of users already browsing the website. So users keep on arriving. So in this case, what you have your input as a test is the arrival rate. You define how many virtual users you want to arrive in your test, and the number of concurrent users inside the system is just a consequence. It's a consequence of the arrival rate and how long it takes for your users to complete, how long they stay in the system, so how long it takes to complete their journey. And if you start having some performance issues, concurrent users inside the system will keep on piling up and piling up. Then a closed workload model is different. It's that new jobs arrival are only triggered by job completions. When your system is at full capacity, new users can only enter your actual system once another user leaves the system. It means that you have a queue in front of the system. So in this kind of system, indeed your input is the number of concurrent users. And if your application starts having some performance issues, it means that the response time will increase, the users will take more time to complete their journey, and they will stay longer in your system, meaning that the system will slow down the arrival rate. So that's why it's very important to pick the proper model for your application. If your application is built in a way that it can push the extra traffic into a queue when it's at full capacity, and typically if you're dealing with a website that can do that, it has an extra screen telling the users that the system is at full capacity and that they have to wait for some time before being able to enter the actual system. We see this kind of architecture typically in gaming or in ticketing. When lots of people try to purchase tickets for an event, the ticketing platform needs to be able to sell the tickets. They mustn't crash, otherwise they typically lose the contract for the competitors. So if you have this kind of architecture, indeed, you're using a closed workload model, and you need to define, you must define your injection profile in terms of concurrent users. I'm pretty sure that just a few people, maybe none, in this assistance in this room have this kind of architecture. There's a very good chance that they don't have this kind of queue and feedback system, and users just keep on arriving, whatever happens. In this case, you cannot reason in terms of concurrent users. You must reason in terms of arrival rate of your virtual users. This point is very important because quite often, both people who are familiar with historical load testing tools have been trained for years to reason in terms of concurrent users. Maybe because originally, because those tools were built in a way that it was more convenient for them to reason in terms of concurrent users. This model probably doesn't match your actual platform. And also, you might have some business people who are familiar with Google Analytics, for example. In Google Analytics, they have this kind of metric, which is number of active users on the system, and they tend to translate this, even if they don't actually know what this metric is, they tend to translate it into concurrent users when they express their performance requirements. And this is wrong. So you need to explain them. Then let's talk about the different types of load tests. People tend to mix load tests, performance tests, stress tests. So let's get the terms right. There are four different very classic kinds of load tests. So the first one is capacity test. In a capacity test, you will increase the load progressively. What you want to figure out is the sweet spot of your application. When the application's performance starts to worsen, and how it worsens. There's probably for some time the response time is increased linearly with the load, then at some point exponentially, and maybe at some point in time the application will crash. And that's something that you want to understand. You want to know how your application behaves in production, so that you'll be able to deal with different events. The stress test, it's one kind of load test. It's not equivalent. It's about wanting to investigate how the application behaves when there's a sudden peak of traffic. Can your application serve, let's say, 10% of your traffic during 10% of the users during a peak, or just 0 or 50? And how does it behave after the peak? Does the application self-heals and goes back to a steady state after the peak? Or is the application just kind of broken and you need to restart your servers and you've lost data because you need to empty some queues, etc.? Another interesting kind of load test is soak testing. So a soak test, also called endurance test. With this kind of test, you want to detect performance issues that only happens after some time. Typically, resources leaks like memory leaks or database connection leaks, these kind of things. And also, maybe some schedule events like suddenly some caches being full and completely flushing, so that when this flush happens, all the users at this point in time experience a super bad response time. And finally, there's the smoke test. So smoke test it's not a real load test. It's actually running your load test with just a few virtual users, a very small load, just to make sure that the load tests are properly maintained and work as expected. Maybe sometimes you're not able to run a full-blown load test on a daily basis or on a weekly basis, but just on a monthly basis. And you want to make sure that during your monthly spot for running your load tests are working as expected, and that you don't have to figure out, oh, we're supposed to run a load test tomorrow, but we haven't maintained them for several months or several weeks, and we need to quickly fix them, but we no longer even know how they are working. The people in charge left the company, so what do we do? So even if you're not able to run the load test on a daily basis, maybe run them on the CI with a very small load, just as functional tests, to make sure that these tests are properly maintained when you modify the application. The next point is about test data. Sometimes you see some people kind of trying to build load tests and running some Postman suite at scale, or trying to run some Selenium tests at scale. And this kind of test is probably not realistic. Why is that? Well, it's because your applications are full of caches. So you have caches in your database. You've probably all experienced, you've been debugging some SQL requests on your database. you execute it the first time, the response time is 500 milliseconds. You execute it the second time, the response time is 5 milliseconds. Why is that? Well, it's because all the joins have been already prepared, all the data is already in memory, just served from memory. Also, if you're building a Java application, you have the just-in-time compiler that will compile some code natively, so super fast. But you want to make sure that you don't want to bypass your caches. You want to test your caches, to use your caches the same way that they are being used in production. So you don't want to hit the same record over and over again, because that's not how things work in production. So if you do that, yes, you will have super great response time, but response times that are way better than what we experience your actual users on your production system. So you need to introduce some statistical distribution in your test data. So don't use static values and inject data, different data into your virtual users. For example, coming from a CSV file to have different credentials, to have different search criteria for your search module. The next point is about how you properly define performance criteria. How do you want to measure performance? For a very long time, the kind of the queen metric was the average value, and people start being aware that it's a very bad metric. Indeed, if you have a bad average response time, yes, you have a performance issue. But if you have a nice average response time, doesn't mean that you don't have 20% of your users who experience poor response time, because you cannot see that with just the average value. So you need, if you check the different shapes that can that your distribution, response time distribution can have, you can see that, for example, you can typically have a long tail of response time up to possibly the request timeout, possibly with some outliers. So you want to figure out if you're not just losing 20% of your business and you don't see it because you just consider the average value. Also, sometimes quite often you have distributions that are multimodal, meaning multiple peaks, each being caused by a different bottleneck in your application. And so you want to investigate this too. Sometimes also we see people using the standard deviation as a complementary matrix to give you a kind of confidence about how good your average value, how meaningful your average value is. It's supposed to describe how far your values are typically from the average value. The trick here is that in maths, standard deviation only makes sense for model distributions. So meaning symmetrical, nice symmetrical curves. Your real-world distributions never look this way. And there's lots of different ways to get get distributions where you wouldn't see that you have an issue if you just consider the average value and the standard deviation. So one nice way that's being more and more used both in load testing and in monitoring is using percentiles. So percentiles are thresholds. The 50th percentile, which is also called the median value, is the value that is above or equal 50% of your values. So it's like, and the 90th percentile is the value that's above or equal to 90% of your values. The 100th percentile is the maximum. This kind of metric is pretty convenient. It's pretty easy to understand for business people, and this way they can easily express performance requirements. They can say, okay, I'm fine with 90% of my users to have response times below 1 second, and I can accept that in 99% of my users, the response time can be up to let's say 5 seconds. And also define the pin 999, 39, etc. So this is a convenient metric. It's convenient because you can easily draw it. It's pretty easy to display, to build charts with it. It's very convenient, as I explained, to build SLAs. Pretty easy to discuss with non-technical people once you've explained percentiles. But there are some tricks. Typically, percentiles cannot be aggregated. And I'm telling this because we see that a lot. I mean a lot. For example, consider those, you have two different data sets. You see in the first data set, the median value, so the 50th percentile is 50. In the second data set, it's 30. If you need to aggregate those data sets together, for example, if you're, so when would you need to perform migration? But typically you have measured percentiles every second, and you want the overall percentile for 1 hour or for your test duration. How can you do that? You will probably try to build an average of the value of the percentiles. And you can see with this example that it's just plain wrong maths. You can see that if we merge the data sets together, the 50%, the median value is 50, but 50 is different from the average value from 50 and 30. So you cannot compute averages on percentiles. It doesn't work, it's broken maths, it's nonsensical, and yet you probably have lots of tools that actually do that. For example, if you use AWS CloudWatch, that's what they do. Also, if you're using a tool that collects monitoring metrics like using StatsD, the StatsD protocol only supports numbers, not array of numbers. So it cannot send distributions to the server, only values. So it can only send computed values of the percentiles. So those percentiles get stored in your metrics database, time series database, and then you're computing averages on percentiles every time you need to compute an aggregation. So you really need to consider how your actual software, monitoring software and load testing software actually work, what they measure, how they store things, so that you get proper stats when you need to build aggregations, and you will. So typically, yeah, so you cannot compute averages on percentiles. It doesn't work. If you try to do that, you'll just smoothen all your hiccups, make all your hiccups disappear, and this is exactly the kind of things that you want to detect and investigate when you have hiccups. Your distributions are never stable over time. So you cannot assume your distributions. Sometimes we also see some tools measuring the average value and the standard distribution. Those are very cheap metrics to compute and to store, and assume a normal distribution, and when they report the percentiles, they just give you the plots on the normal distribution, but they have assumed the normal distribution instead of actually computing it. This is, for example, the test for the JMH framework. I don't know if you're familiar with this solution. It's a tool for building performance tests for Java algorithm. It's a great tool, but just beware that the percentiles are completely fake. It just collects too many events and it doesn't want to introduce more overheads when running the actual test. It's a classical issue with physics where the measure performs the measure messes up with the actual events. And you really want to define performance criteria, acceptance criteria. So for example, some P99 on your response time, some error ratio, so that you can decide the performance of the application in this case is fine, or I have a performance issue that I need to investigate because the behavior is not satisfactory for my end users. When should you be running load tests? The old way. So I'll be comparing kind of the old way and how we're supposed to build things nowadays. The old way was running load tests really at the end of the development lifecycle. Once you've built everything, once you've built you've decided on your architecture, picked your database, picked your frameworks, developed the whole solutions, meaning the whole application, meaning having picked your development guidelines. And in this kind of situation, you just run the load test a few days before going live. And in this kind of situation, the load tests are the bringers of bad news. So in this situation, load tests are the bringers of bad news. It's too late to fix things. Nowadays, you should be trying to run load tests from your continuous integration pipeline. Load tests are another kind of test, and the value of test is to bring quick feedback. You want to quickly detect when you've broken something. Who should be running load tests? Historically, load testing was really a dedicated task for load testing experts, probably a central team in your organization. And those people this organization tend up to be a bottleneck for the project teams. My recommendation is first, you probably should collaborate on load testing, because your performance issues might be in the database, so you need your DBA to have a look at the SQL queries. Might be in the application, might be in the system. So you need to really find a collaborative way to work on load testing. You should probably have the developers maintain the tests. They are the main task force in your organization. Give them a tool that they can use to build and maintain the tests. And use your performance experts not to just maintain tests, but to really investigate and fix performance issues. That's where their core value is supposed to be. And last point is about the tooling. And what's great is that nowadays, we're no longer in the situation we had 20 years ago when we wanted to run load tests, we needed to purchase dedicated machines that would take 6 months to be purchased to be able to build load test environments. Nowadays, we have lots of tools for provisioning instances on the cloud or in private data centers, lots of tools to deploy ephemeral environments, Terraform, Ansible, whatever. We have lots of tools, affordable tools for monitoring the solution to be able to investigate the performance issues, and we have lots of tools like Gatling for generating load against your application and build realistic load tests. Let's have a look at how Gatling works. Oh, sorry, I have a few slides. So Gatling is quite opinionated. Gatling is about crafting load tests with code, not with a graphical user interface. Our point is that, in our opinion, code is expressive. It's easy to collaborate on. You can easily have have reviews from your peers from a pull request, and it's easy to maintain. It's easy to push code into a Git repository and have different versions attached to different versions of the tested application. So Gatling is available in both Java, Scala, and Kotlin. So it runs on a JVM. It integrates nicely with the IDEs like IntelliJ or VS Code, with the build tools such as Maven, Gradle, and SBT. And as it's really source code, you can store it easily in Git. It supports lots of different protocols. So even if the core focus is HTTP and HTTPS and WebSockets, these kind of things, you can also find both official supports for other protocols and also third-party plugins that usually works pretty nicely. Let me just show you what it looks like. Where it is. So here I have a Maven project. But as I said, it could be a Gradle project or an SBT project if you're a Scala developer. So it's pretty easy to set up. There's lots of samples to just directly clone from our GitHub organization. And then you will be really using your IDE to craft, to use our API and craft your tests. So our tests are called simulations. And so you need to extend the simulation class. This sample is quite complex. It's the result of the tutorials on the website. So that's what you would have if you go through them. Here you can see that we are defining a data source. So as I said, trying to inject data into your virtual users, make sure that they don't all do the same thing. So here we're defining, it's a file with some search criteria and some products to select in the CSV file. And here we're saying that we want to pick random entries from the CSV file. We've split the virtual user into journeys, the scenarios, into multiple pieces. What's neat with doing that is that you'll be able to build small components that you can recombine together to build higher level profiles. So for example, you don't have to duplicate your login process everywhere. Just create a constant with that and just reuse it wherever you want. So here we are using, so here we have a search process where the users will first go to the root of the domain, do a post of 1 second, grab a recount from the feeder, so random recount from our CSV file, perform a dynamic GET request. We see here with this pattern with a hash and curly braces. This pattern will be replaced in real time by the data that was coming from the CSV file. And here we are performing some validation on the response to here pass the HTML content and capture a link that we'll save so that we can crawl it just afterward. You can, and what's interesting is that Gatling is really built with a programming language. You can pass functions where where you want to compute complex values. You can just pass a lambda, pass a method reference to compute data from data already stored in the session. So it's really developer friendly. And so ultimately, you'll build scenarios, probably from composition by composing different pieces of workflow. So here we have 2 different populations, regular users and administrators, and you can see that the administrators are doing an extra piece of process. They are doing addition. And ultimately, you'll be telling that this test is about generating that many virtual users, injecting them into those different scenarios, and possibly defining some acceptance criteria. And you can really shape the injection profile the way that your virtual users are being spawned the way you want. You can really build a different kind of test I described before. So we have an open source core that you can use to craft the test, to bootstrap your test when recording from your HTTP traffic, typically from a web browser. You have a reporting engine that generates some static HTML reports at the end of the test. And then if you're interested in going further, we, of course, have an enterprise solution. Sorry. Come on. So we have an enterprise solution that you can use if you want to automate the test and archive the test results and do some comparison and have some live reporting when you run the test. So it's available as a software service. Also, you can also use it with it has a hybrid mode that you can use to generate load coming not only from our load generators on our cloud, but also from your own private network and using your own instances in your private network to generate load against applications that are not exposed on the public internet. Well, and so lots of features available on the different marketplaces of the cloud providers. This is, so like all the talks, you don't have to believe me. The best way is to give it a try, to try for yourself, to read the documentation. We have some comprehensive tutorials on our website, and also we have some free online courses on our community. We have a community forum, so if you're interested in load testing, you might be interested in giving Gatling a try and make your own opinion, honestly. Thank you all. If you have some questions, we have a booth over there, so feel free to drop by either at the end of the conference here or at our booth. Thank you.